Hello, my dear students. Welcome back to your favorite and India's most affordable learning platform, Physics Wala. So, in the last session of physics, where in motion in a plane, we covered lecture number 4. So, where in lecture number 4, we covered the topics related to relative motion. So, we just covered the basics of the relative motion. So, that too, the relative motion in 1D, and I just gave the introduction of relative motion in 2D, right? So today's session we are going to continue with the same topic, that is relative motion. So that relative motion in 2D, the relative motion in 2D. So where we'll mainly focus on the questions based on Rainman problems and river swimmer questions or river boat questions. So whether you are appearing for JEE or NEET or any state level examination, so if the question comes from the relative velocity, so that the probability is very high that they pick from the Rainman problems or river swimmer or river boat questions. So and least probability is so the approaching. So what is the shortest time taken by two objects to collide? Okay, what is the shortest time or shortest path between the two objects? So that also which comes under relative motion in 2D, which we will discuss in the next session. So today's session we are going to focus on these two topics where the concept can be understood by doing the questions. Okay, so I am taking 10 questions related to these topics so that every concept will be covered through the question based on this. So whatever the questions that are asking from in the previous years, so like JEE or NEET or any other state examination, so those standard type of questions I have taken and I am explaining those. So apart from this, you need not to go any further reference books or anything related to Rainman problems or river boat questions. If we have time, you can go through, because to check the understanding levels, so whether you are able to do the new questions based on these topics or not, you can do that. But once you understand the to understand the concepts, so whatever the questions that I am taking, those are more than sufficient. Okay, chalo. So as usual, for the next 1 hour or 1.5 hours, just be with me. Avoid all the disturbances around you guys, and it's very important to prepare your short notes at the end. Okay, so spend just 10 to 15 minutes after the class, prepare your own short notes, and that will be useful for you at the time of any cumulative examination, right? Chalo. So with a very positive energy, let's begin the today's session. So completely the understanding of the concepts through the questions. So let's go for the first question. So if you are already aware of this concept, just pause the video and try it on your own. That's the best way to learn, guys. Okay, chalo. So the first question: rain is falling vertically downward at the rate of 3 km/h. A man walking due west at 4 km/h opens his umbrella to protect himself from the rain. So at what angle he should point his umbrella? So now understand the question. Here the vectors knowledge is very important to understand the relative velocity first of all. Okay, rain is falling vertically downward. Let's represent the diagram. So rain is falling like this, vertically downward. So at the rate of 3 km/h, so the velocity of rain, so let's decrease the size. So let's write, so the velocity of the rain with respect to ground, so velocity of the rain with respect to ground, so it is falling vertically downward. So that's why I'm taking this as minus 3 j cap, minus 3 j cap. The vertically downwards means minus j cap, right? So magnitude is 3, so minus 3 j cap is the velocity of the rain with respect to ground. And see here, a man is walking due west, opens his umbrella, a man is walking due west at 4 km/h. So which side is moving? So west side, this side. Okay, so with how much speed? 4 km/h. So the velocity of the man with respect to ground, understand the terminology properly. So the velocity of the man with respect to ground, so is going to be 4 km/h. So as it is towards west, you know the directions, right? So standard directions we considered east, west, and then north, south. Yes or no? Now, so towards west, that's why. So shall I say this as minus 4 I cap, minus 4 I cap. Now So opens his umbrella to protect himself from the rain. So at what angle he should point his umbrella? So at what angle he should point his umbrella? First thing, generally, let's suppose, so you are standing straight. Okay, so let's suppose rain is falling vertically downward. So then when you open umbrella so straight, so then you will be protected from the rain. Yes or no? When you are just standing and rain is also falling vertically. Okay, so but you are standing and rain is falling like this. So if you stand umbrella vertically, you will not protect yourself from the rain, right? So what you should do? You should bend your umbrella so to the direction of rain. So this side you should protect your bend your umbrella, right? So in the similar way, or else let's suppose, so the rain is falling straight. So and then, but you are moving. Just hope you guys have already faced this issue in some time, right? So let's suppose the rain is falling straight. So but we are going on a vehicle. So then how we feel? So the rain is hitting our face, like it's coming like to our face, right? So have you ever faced this, right? So we hope everyone faced this, right? So now see, the rain seems to be coming like this. So then what we do? So we hold the umbrella at some angle. So the same thing is happening. So the rain is falling vertically, but the person is moving. So as the person is moving, so what happens? Rain seems to be falling on his face vertical, like this, with some inclined angle, right? So then what he should do? He should bend his umbrella, right? He should point his umbrella in the direction of rain. So then with vertical, how much angle he is bending his umbrella? That's the question. Okay, now understand the mathematical part or vectors part here. So minus 3j cap minus 4j cap. First, what's the given information? See here, the velocity of the rain with respect to ground is given, which is minus 3j cap. And then what is the velocity of the man with respect to ground is given? So that is minus 4I cap. Now with respect to man, how the rain is falling? Okay now, so with respect to man, how the rain is falling? So what is the expression for that? Velocity of the rain with respect to man, shall I write? So if you know how the rain is falling with respect to the person, then he could hold his umbrella in that direction. That's it. Yes or no? So the velocity of the rain with respect to man, which is going to be velocity of the rain minus velocity of the man. So with respect to ground, here vectors plays the important role, the relative velocity concept and vectors, right? So then the velocity of the rain with respect to man, so is equals to, so what is this one? Velocity of the rain with respect to ground, so which we got it as minus 3j cap, and then minus of velocity of man with respect to ground, so minus 4I cap. So then this comes out to be 4I cap minus 3j cap. So velocity of rain with respect to man. So see here, we need the velocity of the rain with respect to man, which is equals to 4I cap minus 3j cap. So what does it mean by 4I cap minus 3j cap? So can you draw the diagram for that? So 4I cap. So this is minus 4I cap. So this is going to be 4I cap. This is going to be 4I cap. And then minus 3j cap. This is a minus 3j cap. Yes or no? So then the rain is falling, the resultant of these two. So see here, the velocity of the rain with respect to man is nothing but, shall I write, 4I cap plus minus 3j cap. So you have to, the resultant of these two, the resultant of 4I cap and minus 3j cap will result in the velocity of the rain with respect to man. So what is the resultant due to these two? So 4I cap is this, minus 3j cap is this. So then the resultant will be in this direction. So that means the rain is falling on the person in this direction. The rain is falling on the person in this direction. Okay, the person is moving from here. See here. So let's suppose I am the person who is moving with 4 km per hour due west. So let's suppose I am moving like this. Okay. So then the rain is falling on me like this. Okay. Now, so the rain seems to be falling on me like this because I am in motion. Okay. So that's why I should hold my umbrella this way, right? So with what angle? With respect to the vertical. So with respect to the vertical, so this is the angle that I should hold the umbrella. So what is this angle? This one is the angle, guys. This is the angle with which you should hold his umbrella with respect to the vertical. That's it. Concept is done. So now you can just do the basic maths. So what you can do, so this is, see, if you parallel shift this vector to this side, this is 3, so this is also 3. So you could see this is 4, this is 3, obviously this is going to be 5. The rain is hitting him at the speed of 5 km per hour. The rain is hitting him at the speed of 5 km per hour, or else you can find from here the velocity magnitude. If you find, it's a speed, so which is nothing but square root of 4 square plus minus 3 whole square, so which is nothing but again 5. Velocity with which the rain hitting him is 5 km per hour. So 5 km per hour in which direction? So shall I say that, so this angle so is going to be, so this is 37 degrees, we know this because opposite to 3, 37, and then this must be 53 degrees. If it is 53, this is also 53. So I can say that with respect to vertical, he is holding his umbrella 53 degrees. Which side? Due west. Check the options. 37 degrees west of vertical. No. 37 degrees. No. 53 degrees west of vertical. Yes. 53 degrees west of vertical. And then 37 degrees east of vertical. East. No. So 53 degrees east. This side they are talking about. No. Understood the concept, everyone? Just by looking at the question you can answer this. So do you need to go for all these? Just if you understand the diagram, that's it. So if it is 3, this is 4, obviously the resultant is going to be 5, and this angle is 37, this is going to be 53, so this will be 53, vertically opposite angles, right? Done? Clear? Chalo. Hope you guys understood this question. So now, so let's go further. Chalo. So let's take one more question. A man walking due east with 3 km per hour observes rain falling vertically at the rate 3 km per hour. So find the actual speed and the direction of the rain with respect to the vertical. So first let's take the directions like this, or else let's write a man is walking due east. First let's suppose, so here is a man who is walking at 3 km per hour due east. Let's consider 3 I cap, right side east, and then he observes rain falling vertically at the rate of 3 km per hour. So on him the rain is falling 3 km per hour minus 3j cap. So minus 3j cap. So find the actual speed and direction of the rain with respect to ground. So first, what is the given information? That's a main point. That's a very, very important point. So the velocity of the man with respect to ground is given. So the man is walking at the speed of 3 I cap, 3 km per hour means, so I can write velocity of man with respect to ground is 3 I cap km per hour. So no need to write the units, just write the mathematical part. So chalo. So 3 I cap. So let it be. So then, so he observes, the man observes rain falling vertically at the rate 3 km per hour. The man observes means with respect to the man, the rain is falling at the speed of 3 km per hour. So that means what they gave, the velocity of the rain with respect to man is given. Is this point understood? See here. He observes, the person observes rain falling vertically at the rate of 3 km per hour. With respect to the person, the rain is falling at 3 km per hour. So, okay, this point is clear, which is nothing but velocity of the rain with respect to man is given. So how much? Minus 3j cap. That's it. So then what they are asking, what is the actual speed? What does it mean by actual speed? So this means, so what is the velocity of the rain with respect to ground? They are asking the magnitude of velocity of the rain with respect to ground. Speed means, so the magnitude of the velocity, right? See, the basic things matters a lot. How you read the question, how you write the given information, this all will matter while doing a physics numerical. Keep this thing in your mind, guys. Whenever you are going for any chapter, the basics matters a lot. Okay, so first strengthen your basics. So whether it's vectors, whether it's basic mathematics, whatever it is, are the basics related to that particular chapter. So all these things are very, very important. Okay, chalo. So now let's see, they are asking what is the velocity of rain with respect to ground. So first here I know what is velocity of the rain with respect to man formula. So what is that? Velocity of the rain minus velocity of the man. So here two main things, let's keep them as a subject. The simple logic is rain is one main thing, the person is the another main thing. So how the rain is falling with respect to man? So let's keep that those two. Okay, so if you are not getting any idea, so what are the two main objects? Let's make them the subject. That's it. Okay, chalo. So now I got what is this velocity of the rain with respect to man? Minus 3j cap, which is equals to velocity of the rain with respect to ground. We have to find. So minus. So what is the velocity of the man with respect to ground? So he is moving due east. He is moving due east. So that's why it's going to be 3I cap. So then velocity of the rain, so which is equals to, send this to this side. So 3I cap minus 3j cap. So this is the velocity of the rain with respect to ground. So then can we draw the diagram for this? So velocity of the rain with respect to ground is 3I cap is in this direction. I can write 3I cap is in this direction, and then 3j cap. So what is the 3j cap? So the 3j minus 3j cap. So minus 3j cap is in this direction. Yes or no? Understanding? Yes? Correct only, right? So velocity of the rain with respect to man is velocity of the rain with respect to ground, velocity of the man with respect to ground. Yes? So then this is going to be comes plus. Yes, fine. So this is 3I cap minus 3j cap. Yes, fine. So 3I cap. So we can also write this as velocity of the rain with respect to ground as 3I cap. So plus minus 3j cap. So if you write like this, it will be even better. So then what will be the resultant? So the resultant will be so like this. So yes or no? So the resultant will be like this. So then, so what is the speed? So this is 3, this is 3, the angle between them is 90. Obviously, so the velocity of the rain with respect to ground. So then I can do through numerical as well. So let's see, by formula also you can do. So how? So the velocity of the rain with respect to ground, so the magnitude is equals to square root of 3 whole square plus square root minus 3 whole square. So which is nothing but, so square root of 3 root 2. Yes or no? So that's what we got, 3 root 2 kilometer per hour. So this is the velocity of the rain with respect to ground. So the first question is done. So find the direction of the rain with respect to vertical. So with respect to vertical, so what, rain is falling this way, right? Rain is falling this way. So what is this angle we can find? So this is 3, obviously this is also 3. So right, so the opposite is 3, the adjacent is 3. So this is 45 degrees. Obviously this will be also 45 degrees. So that this is also 45 degrees. Yes or no? If it is 45, the remaining must be first 45. Why this is 45? Opposite is 3, adjacent is 3. So tan theta is equals to opposite by adjacent. So 3 by 3, 1. So tan theta is equals to 1, theta is equals to 45 degrees. Basic maths, right? So if it is 45, this is 45. So this is 45. So then this is a speed. The speed is equals to 3 root 2 kilometer per hour. And then the next question is direction. So what's the direction? The direction is, it's 45 degrees. 45 degrees. So west of vertical. 45 degrees west of vertical. So to the west side, right? So that's what west of vertical. Same previous question type. Done? Understood the concept? So now let's go for the another question of Rainman problems. See here. So let's go for the another question. So what's the question says here? A standing man observes the rain falling with the velocity 20 meter per second at an angle of 30 degrees with respect to the vertical. See here. So consider this is a vertical. Consider this is a vertical. So now let's suppose a man is standing here. Consider a man is standing here. So let's suppose the Chintu is standing here. Okay. So the rain is falling at an angle 30 degrees on him. So the rain, he observes that he is standing, he is stationary, but the rain is falling slant like this at an angle 30 degrees with respect to the vertical. 30 degrees with respect to the vertical. So this point is clear now. So find the velocity with which the man should move so that the rain appears to fall vertically to him. Now, interesting question. See, this question you can solve it in just 10 seconds. Okay, so there are two methods. First, let's go for the formula method. Then I'll go for the concept, like trick method. So the simple trick method. Okay, so first let's do by the formula. So first what is the rain velocity of the rain? So the person is standing, right? So the velocity of the rain with respect to ground. So the magnitude of the velocity of the rain with respect to ground, so which is given as 20 meter per second, right? The rain is falling 20 meter per second at an angle 30 degrees, at an angle 30 degrees. So shall I write two components for the rain? So this is one component. See, if this angle is 30 degrees, so this angle is also going to be 30 degrees, obviously vertically opposite angles. So then the rain will have, velocity of the rain will have two components. What are the two components? This is going to be 20 sine 30. This side sine component will come. So this side cos component will come. So 20 cos 30. 20 cos 30. So then this is going to be 20 into. So what is cos 30? The cos 30 value root 3 by 2. So this is going to be 10 root 3. Let it be. So then, so what is this one? The velocity, this is 20 into 1 by 2, so which is nothing but 10 meter per second. So this is going to be 10 meter per second. So now, so the concept is the velocity of the rain with respect to ground has now two components. What is the two? What are the two components? 10 I cap minus 10 root 3 j cap. Yes or no? So 10 I cap and then 10 root 3 j cap. This point is clear, and the angle we have got. So then, can we write, so what is the velocity of the rain with respect to man formula? So what is the velocity of the rain with respect to man formula? So now, the first thing is, so let's suppose the velocity of the rain with respect to ground minus velocity of the man with respect to ground. Velocity of the rain with respect to ground minus velocity of the man with respect to ground. So he said in the question, so or else let's write this as 10 I cap minus 10 root 3 j cap. So what is the velocity of the rain with respect to ground? What is the velocity of the rain? Sorry. Velocity of the rain with respect to man. See here. So what is the velocity of the rain with respect to ground? This is going to be 10 I cap minus 10 root 3 j cap. This point is clear. Now, so velocity of the rain with respect to man. Find the velocity with which the man should move so that rain appears to fall vertically on him. So for the person who is walking, or for the person who is moving with a speed, so the rain seems to be falling vertically to him. Okay, so that means the velocity of the rain with respect to man should be equals to, so shall I say the complete thing should be vertically. So let's suppose this is minus a j cap I am writing. Vertically means minus j cap. So I am considering with some velocity, with some magnitude, that is a. Understanding this point? See here. With which, find the velocity with which the man should move. So the person should move with what velocity, and so that the rain seems to be falling vertically to him. The rain seems to be falling vertically to him. So with some velocity a, and vertically means minus j cap. Okay. So let the person is moving with some velocity v. Let the person is moving with some velocity v. So what is that velocity v? So what is that velocity v? So in which direction he should move? So in the x direction. So v I cap. So clear this part. So now let's write this one. So we have got, so the minus a j cap is equals to here 10 minus v I cap. So minus 10 root 3 j cap. So minus 10 root 3 j cap. See, if you want to do, if you don't want to change this, so just let it be. So velocity of the rain with respect to man, so let it be some quantities. You put some dash and then j cap. So minus j cap, because it should be vertically downwards. So that's why minus j cap. So whether you put x or y, we don't know. Okay. So but it should seems to be, the total velocity seems to be vertically for the person. The rain should seems to be falling vertically to the person. That's why minus j cap. So the magnitude can be anything. So we are not bothered about the magnitude. So now, with what velocity the person should move? That's the question. With what velocity the person should move? So for that means, see here, see this point. So seems to be falling vertically to him. So that means the x component should be 0. The horizontal component should be 0. So what is the horizontal component we got here? So the 10 minus v is the horizontal component I cap. So this must be 0. So therefore the person should move with some 10 meter per second. That's it. So with what velocity the person should move? 10 meter per second. This is mathematical way. So first we considered what is the velocity of the rain with respect to ground. Two components I drew. And then velocity of the rain with respect to man formula I can write as velocity of the rain with respect to ground minus velocity of the man with respect to ground. So this should be vertically, completely vertically. That's why minus j cap. So the magnitude can be anything. So and this I wrote. So whatever we got it here. So 10 I cap minus 10 root 3 j cap. So let's suppose the person should move with some velocity v, so that his horizontal component, his velocity is cancelling out the horizontal component. So let that velocity be v. The person is moving with velocity v. So in the x direction. So then, so simply the y, only y component should be there. So the x component, because the rain seems to be falling vertically to him, should fall to be vertical. So that's why the horizontal component should be 0. So 10 minus v is equal 0. So the v is equals 10 meter per second. So that means the person should move 10 meter per second. That's it. That's a person should move 10 meter per second. This is the mathematical way. So now what is the method 2? Method 2, which is the simplest method, trick. See here. So the thing is, first the rain is falling at a speed of 20 meter per second at an angle 30 degrees with respect to the vertical. So that we have two components here. So one component is, so this side we got 10 meter per second. The rain horizontal component is 10 meter per second. And then the rain has vertical component 10 root 3 meter per second. 10 root 3 meter per second. So now the thing is, with what velocity the person should move so that the rain seems to be falling vertically on him. Okay now. So that means there should be only vertical velocity. If the person moves with a velocity which is exactly equals to the horizontal component of velocity rain, then so the relative velocity between horizontal component of velocity and the person's velocity will be 0. Again understand this statement. So the horizontal component of the rain has velocity 10 meter per second. So if the person also moves with same 10 meter per second, then there is no relative velocity between the person and the horizontal component of the rain. Yes or no? So then the component that only exists is going to be the vertical component. Yes? So that's why the person should move with a velocity which is equals to the horizontal component. So that's why the person's velocity must be equals to 10 meter per second. That's it. That's it. Just by the diagram method. If he moves with the same velocity which is equals to horizontal component, then there is no relative velocity between the horizontal component of velocity and the person's velocity. So and the only component that exists will be the vertical component. Yes or no? Clear? So rain is falling straight. So if you are moving, then what it seems to be? It seems to be falling on you with some vertical angle, right? But the rain is already falling vertically. So but if you move with some velocity which is equals to the horizontal component of velocity, then rain hits you vertically. That's the logic. Clear? Sure. So already rains are falling, you can try. So try this next question, guys. Let's move to the next question. Hope you guys can solve this question easily now. So a man standing on road has to hold his umbrella at 30 degrees with respect to vertical to keep the rain away. So okay, so that means he is holding umbrella 30 degrees means the rain is falling at the angle of 30 degrees with respect to the vertical. So that means the rain is falling like this. The rain is falling. So with respect to the vertical, this is the vertical. So the rain is falling 30 degrees. So the person is standing here is holding the umbrella. So the person standing here holding the umbrella. So okay. So now with vertical to keep the rain away. So he throws the umbrella and then starts running at 10 km per hour. So then he finds the raindrops hitting vertically. So then what is the speed of rain with respect to ground? What is the speed of rain with respect to ground? So again, so the simple question. So they are saying that he throws the umbrella and starts running at 10 km per hour. So he first the rain is falling at 30 degrees. The rain is falling at 30 degrees. So the person throws the umbrella and starts running at 10 km per hour. So the velocity of the person, it's going to be 10 km per hour. So then he seems that, then he finds that raindrops are hitting vertically. So when he is moving with 10 km per hour, so the raindrops are hitting him vertically. So that means, shall I say, the horizontal component of the rain, the horizontal, if it is 30, this is going to be 30. So then the horizontal component of the rain, what is the horizontal component of the rain? So let's suppose the velocity, rain velocity is VR, velocity of the rain. So this side it's coming out to be VR sin 30, and then this side it's coming out to be VR cos 30. Yes or no? So then shall I say that the horizontal component of the velocity is equals to the person's velocity, then only the rain seems to be falling vertically on the person, right? So that's why VR sin 30 must be equals to the person's velocity. What is the person velocity? Person velocity 10 km per hour. So then there is no relative velocity between the horizontal component of the velocity and the person's velocity, and the rain seems to be falling only vertically, right? So then they are asking what is the speed of the rain. So that means VR they are asking. So VR into sin 30 is 1 by 2 is equals to 10. So from here velocity of the rain is 20 meter per second. So the velocity of the rain is going to be 20 meter per second. Option C is the correct one. Simple question. Just no need to put pen also. Just you can just have the figure in the mind and you can solve it. Done? So this is about the Rainman problems. So any other questions related to Rainman? No. So I have considered 4 questions. So based on the topics that I have taken, only these topics will be repeated every year. Okay. So you solve the other questions, whether like follow the method which I told you or some other method, because the relative velocity questions can be solved by many different methods, not only one method, many methods. So this is one of the method, so which I am adapting. So if you are able to understand this, you adopt this method. Otherwise, so whatever the method you are just understanding, so just do that method. But at the end, we require answer only, right? Okay, clear? Sure. Chalo guys, so let's go for the river swimmer questions or river boat questions. So river swimmer or river boat problems from here. So the next 6 questions are going to be based on this only. Chalo. So first, so see here, what's the question says? A man can swim at 4 km per hour in still water. So let me add one slide and explain the basic concept related to riverman problems, guys. So river, boat or swimmer problems. So first let me explain you the basic terminology related to that, then we'll go for the questions directly. Okay. So first let's suppose this is a river. So this is said to be the river width. This is the width of the river. And then, so the basic thing first, let's suppose the river is flowing this side. So this we call it as, so the river is flowing at the rate of some 4 km per hour, 3 km per hour, they may mention in the question. So sometimes the flowing rate or the river speed, they might mention current. Current means again the river speed. If they say the current, so that means that's a river speed, river flow speed. Okay. So now, so if the person starts swimming from here, the first thing is if the person starts swimming, so like this, if sorry guys, if the person starts swimming from here, so then, so what he expects actually, if he starts from here, he thinks that he'll reach this position. But due to the river flow, what happens for the person who is observing from the ground, so this person will move this way because of the river flow. The river will be thrown towards the right. The river throws the person to the right because of the river flow, right? So that's why the person reaches. This is the velocity of the, let's suppose, swimmer with respect to ground. Velocity of the swimmer with respect to ground, right? So then whatever the distance that he moved from his vertical distance, actually he started here, he wants to move here, but he reached there. So this distance which in the x-axis, it's called drift. This distance in the x-axis, it's called drift. Okay now. So then this is a velocity of the swimmer. This is a velocity of the swimmer with respect to river. So and this is a velocity of the river with respect to ground. This is a velocity of the river with respect to ground. This is a velocity of the swimmer with respect to river. Understanding guys? Clear? Chalo. So now if you need how much time, the time taken to cross the river, the standard questions that they ask, the time taken to cross the river. So always remember the time taken will be equals to, so the vertical distance by, so the time taken is the distance by speed, right? So the vertical distance by the vertical speed, remember this always. So the vertical dy means the vertical distance, that's a river width, okay, and the what is the vertical velocity that he is maintaining, so the vertical velocity with which he is moving, so that's a river drift. Okay, so the time taken by the person to reach the other destination. And one more point here, that is, if the person wants to reach exactly the opposite bank, so if he starts here, so then due to the river flow he will move this side, yes or no? So then, so if he wants to reach exactly this position, so then he should start at an angle theta with respect to the vertical. So he should start at an angle, so if he wants to reach exactly opposite bank, if he wants to reach exactly the opposite bank, so then, so he should start swimming, at an angle theta, so that is to the west with respect to vertical, like in this situation I am talking about. Okay, so with respect to the vertical. Clear? Understood guys? And then, so what if the person starts swimming at some angle already, right side? So for example, if the person actually starts swimming like this, so then he will not reach this position, he will reach some other position, because due to the already he is moving in this direction, and due to the river flow again he will throws to the right. So that's why he reaches some other point here, he reaches some other point which is there here. Clear? Understood guys? Everyone, this concept. So again we'll understand these terms now through the questions. That's just the basic understanding what are the terminology. Okay, so now let's see here. So the first question, see here, a man can swim at 4 km/h in still water. So let's suppose this is a river. So this is a river. So the man can swim at 4 km/h. So let's suppose the man is here, so he wants to swim 4 km/h. So the velocity of the swimmer with respect to ground is 4 km. The velocity of the still water, so that means velocity of the swimmer in the river, due to the river, which is 4 km/h. Let's write only 4, so let it be. So he is crossing a 8 km wide river. This is a 8 km wide river now. So then, which is flowing at the rate of 3 km/h. So this is a velocity of the river with respect to ground, so which is equals to 3 km/h. 3 km/h. If he swims perpendicular to the river flow, so then calculate the speed of the swimmer as seen by an observer on the ground. So what we have to find? So what is the speed of the swimmer with respect to the observer on the ground? For this observer, so this person seems to be moving in this direction, yes or no? So this, for this person who is observing from the ground, so this swimmer is actually swimming perpendicularly, but due to the river flow he will be thrown to the right, he will be thrown to the right. So that's why he reaches this point. So this distance we call it as drift. This distance we call it as drift. Okay, so now he is asking what is the speed of the swimmer with respect to the person on the ground. So first let's write, so what is the velocity of the swimmer with respect to river? So what is the velocity of the swimmer with respect to river? So which is equals to velocity of the swimmer minus velocity of the river with respect to ground, with respect to ground. Yes or no? With respect to ground, with respect to ground. So what is the velocity of the swimmer with respect to ground? That we have to find. And velocity of the swimmer with respect to river, it is 4 I cap, right? 4 j cap, sorry, which is 4 j cap. I can say he is swimming perpendicular to the river flow, that's why 4 j cap. So velocity of the swimmer with respect to ground we required, let it be. So minus what is the velocity of the river with respect to ground, 3 I cap, right? So from here velocity of the swimmer with respect to ground, so will be equals to 4 I cap minus 3 j cap. So 3 I cap plus 4 j cap, send it to that side. So 4 I cap, 3 I cap plus 4 j cap, this is a velocity vector, but they are asking speed of the swimmer. So what is the speed now? The magnitude of the velocity, so which is square root of 3 square plus 4 square, so which is nothing but 5. So simply you can say that directly. So this here is moving with 4 meter per second, yes or no? And here, so whatever the drift speed, it will be same as the river speed. Horizontally will be having only the river speed, right? So here the speed will be 3, here it will be 4, obviously this will be 5, no need to go for the calculations also. So that's a first question. So then what is the time taken to cross the river? So the second question is, what is the time taken to cross the river? The time taken to cross river. So what is the time taken as we discussed earlier? So the distance in y by velocity in y. So the distance in y is nothing but, so the width of the river 8 by, so what is the velocity, vertical velocity? So vertically is moving with 4 km per hour, right? So 4 kilometers is going to be the vertical velocity, that's why 2 hours is a time taken, yes or no? So then the third question, what's the third question says? That's a drift. So drift is nothing but, so drift is a distance actually. Drift is a distance. So what is the distance formula? Speed into velocity, right? Speed is equals to distance by time. So distance is equals to speed into time. So drift is there in which direction? Drift is there in x direction, right? Drift means from here to here. So drift is there in x direction. So that means the x direction velocity into the time taken, right? So what is the x direction velocity? So the velocity in the x direction is only the river velocity. So the Vx you can take 3 into, so the time t. So what is the total time taken? 2. So that's why, so 6 kilometers is a drift. So this is how you solve the questions. Clear? The first concept of the river boat questions or river swimmer questions, everyone? Done? Now let's move further. So what's the next question says? See here. A man can row a boat 4 km per hour in still water. He is crossing a river where the current is 2 km per hour. 2 km per hour means current means river speed. If he wants to reach a point other bank on the other bank directly opposite to the starting point, so in what direction he should row his boat? So as we discussed earlier, see here, this is a river. So the first thing is, a person is rowing his boat at 4 km per hour, fine. So the river speed is given. So what is the river speed with respect to the ground? So it's given as 2 km per hour, let it be. So if he wants to reach exactly the other opposite bank, so if he starts from here, the person starts from here, so he wants to reach exactly this point. So obviously he should not move perpendicular. He should not move perpendicular. He should move with some angle theta with respect to the vertical. He should row his boat with respect to the vertical at an angle theta. This is for sure, right? So then with what speed he is rowing his boat? 4 km per hour. So this is a 4 km per hour. Yes or no? So then what is this? What is this one? Shall I say this is going to be, what is the velocity here? This horizontal component, only the velocity that we will be having is 2, because the river speed is going to be the horizontal velocity, the only velocity that is existing, right? So that's why, so he's 4 km per hour here, and then this is 2 km per hour. So if we need theta, so then sin theta is equals to, so we can simply write, so velocity of the river by the velocity of the swimmer, so which is nothing but Sin theta is equals to, what is the velocity of the river? 2. Velocity of the swimmer? 4. So therefore sin theta is equals to 1 by 2. So from there theta is equals to 1 by 2. So therefore theta must be equals to 30 degrees. Sin theta 1 by 2. So theta must be 30 degrees. So that with what angle he should move? 30 degrees with respect to the vertical. So the first question answer is, so the swimmer or the boat, he should row, the man should row his boat at an angle of 30 degrees west of vertical to reach the opposite bank. So to reach the opposite bank. Clear? This is the first question. Next, what is the resultant velocity of the boat as seen by the observer on the ground? So let's suppose, so the person on the ground is here. So with respect to this person, how this boat seems to be rowing? See here. So for this person, so this boat, this is the velocity of the swimmer or velocity of the boat with respect to ground, because he is moving like this, but due to the river flow he will be thrown to the right. So as a result, so for the person who is observing from the ground, so the boat moves to be in the straight line like this, right? So this is 2, this is 4. So obviously this is going to be how much? So square root of so I can write this here. So this is 2, this is 4, right? So obviously this is going to be sin theta is equals to, or else just use the Pythagoras theorem. So then 4 square is equals to 2 square plus x square. So then this is going to be x square is equals to 16 minus 4. So this is going to be 12. So then x is equals to root 12. So then which is 4 into 4 means 2 comes out. So 2 root 3, I guess. Yes. So this is going to be 2 root 3 kilometer per hour. Understood? So this is a speed with which the person moving or the boat is moving with respect to the person who is observing from the ground. So just I applied the Pythagoras theorem here. This is 2, this is 4. Okay. So then I got this as per Pythagoras theorem, I considered it as x. So we got 2 root 3. Okay. So the second question answer is 2 root 3 kilometer per hour. So the first question answer is 30 degrees, theta is equals to 30 with respect to vertical, right? So then next, so the third question, if the width of the river is 33 kilometers, it's not 33 guys, it's a 3 root 3. Here printing mistake is given, so it's a 3 root 3. Note this down. It's a 3 root 3 kilometers. Find the time taken by, so what is the time taken formula? So I can write, so the third question, the time taken is equals to, the distance in y by the speed in y. So what is the distance in y? The width of the river. So what is the width of the river? 3 root 3. So by what is the speed in y? So the speed in y is nothing but this one, which is 2 root 3. So the speed in y is 2 root 3. So root 3 cancel, 3 by 2. So which is 1.5 hours. So or we can say 90 minutes. So whatever. So 90 minutes or 1.5 hours. So whatever you can consider. Clear? Done? Sure. So let's go for the next question. So let's go for the next question, guys. See here. A person swims in a river aiming to reach exactly opposite point on the bank of a river. His speed of swimming is 0.5 meter per second at an angle 120 degrees with respect to the direction of flow of water. So then the speed of water stream is, very simple question. See here. So this is a river. Okay. First, so he wants to reach exactly the opposite points. Let's suppose the person starts swimming from here. So if he wants to reach the exactly opposite point, obviously he should start swimming at this angle. He should start swimming with some angle theta. So now his speed is 0.5. So this is 0.5. This is going to be 0.5 at an angle 120 degrees with respect to the direction of flow. So this is the direction of flow of the river. So this total angle is, they are saying 120. So this is already 90. So obviously this angle is going to be 30. Obviously this angle is going to be 30, right? So then what they are asking? They are asking what is the speed of river. So speed of river, let it be VR. Yes or no? Velocity of the river. So if it is VR, here the velocity will be VR. This is the velocity of the swimmer. So simply in this triangle you can write sin 30 is equals to opposite. What is the opposite? Velocity of the river. Yes or no? Horizontal velocity that exists, only thing is velocity of the river by the velocity of the swimmer. So this is going to be 1 by 2. So which is equals to velocity of the river by velocity of the swimmer. So from here, so velocity of the river is equals to velocity of the swimmer by 2. So what is the velocity of the swimmer? 0.5 by 2. So which is 0.25 meter per second is the river speed. So option C is the correct one. Very easy question, right? Sure. So now what is the crossing the river in shortest path? So how do you cross the river in shortest path? So the thing is shortest path, right? So the shortest path is going to be, so whenever if the person starts swimming, this is the river. Understand this concept. The shortest path is going to be the vertical distance always. Yes or no? If the person starts here and reaches here, this path is going to be the shortest path. This path is going to be the shortest path, I can say. Yes or no? So if you take from here to here, it's going to be larger than this one. So the perpendicular distance will be always the shortest path. Yes or no? So that's why, so to reach here, we know that the person should start swimming at an angle. This is the velocity of the swimmer at an angle theta. So and here what will be having? So velocity of the river, yes or no? So there, that's why, so to cover the river or to cross the river, so the along the shortest path, he should start swimming. So he should start swimming, at an angle theta with respect to vertical. Theta with respect to vertical. Yes or no? So theta with respect to vertical. So then can I say, shall I write the condition that for the shortest path covering, so the sin theta must be equals to VR by Vs. VR by Vs. So this is a condition to cross the river along the shortest path. To cross the river along the shortest path. Along the shortest path. Clear, guys? Everyone understood? So let's move further. So the next question, see here. So the speed of a swimmer in still water is 20 meter per second. The speed of the river water is 10 meter per second and is flowing due east. If he is standing on the south bank and wishes to cross the river along the shortest path. So wishes to cross the river along the shortest path. Consider this is a south bank and he wants to reach exactly this point. And then the speed of the swimmer is going to be 20 meter per second. So the velocity of the river is 10 meter per second. They said it in the question, right? So then is flowing due east. So he is standing on the, so fine, shortest path. The angle at which he should make his strokes with respect to the north, so is given by, with respect to, this is a south bank, so he has to move to the north bank with respect to north. So at what angle he should move, right? So that this is nothing but, this is going to be theta. This is the velocity of the swimmer. Here the velocity that exists is a VR. And for the shortest path, what is the condition that we know? The sin theta is equals to VR by Vs. So what is the theta? We have to find. So what is VR that is given in the question? Velocity of the river. So the water is flowing at a speed of 10 meter per second. So what is the velocity of the swimmer? 20, right? So sin theta is equals to 1 by 2. So from here theta must be equals to 30 degrees. That's it. Theta must be equals to 30 degrees. So 30 degrees to west. 30 degrees to west. Clear? Understood? Chalo, simple question. Very simple question. So next question. Next question, guys. So what's the question says here? The speed of the boat is 5 km/h in still water. It crosses a river of width 1 km along the shortest possible path in 15 minutes. So the velocity of the river water. See, first draw the diagram. So this is the river. So the width of the river is given. So what's the width of the river? So the width of the river is 1 km. Fine. So then, so the speed of a boat is 5 km/h in still water. So the shortest path means, so he's moving in a, if the person is here, so he's moving this side, right? He wants to reach this point, and then he's moving at a speed of 5 km/h here. This is a 5 km/h. So what's the time taken? So 15 meters, right? So then this is going to be the angle theta. So what is the velocity of the river? So they are asking what is the velocity of the river. So first, so the first thing is VR we have to find. So we know this one, and we don't know what is theta, and we know the vertical distance. So first, can we find what is the time taken? So first, can we find what is the time taken? What is the time taken? So see here. So the 1 kilometer, right? This one, yes. So 1 kilometer. The time taken is equals to the vertical distance by the vertical speed. So they gave in the question that the time taken is 15 minutes, right? So 15 minutes means, shall I write 15 by 60 to hours? I am converting. Okay. So then distance in y. So the distance in y is nothing but, so 1 kilometer. So let's write it as 1 by, so because this is in hours, so let this be in kilometers itself. So and then velocity in y is going to be vy. So shall I say the vy, this is going to be 1 by 4. So then vy is equals to 4 km/h. So what is the velocity in y direction? So that is 4 km/h. So this velocity is going to be 4 km/h. So but what we required actually, velocity of the river. They are asking what is the velocity of the river. So this is 5, this is 4. Obviously this must be 3 km/h. Yes or no? So no need to think also. So that is going to be just a right angle triangle, right? So this we got 5, and this we got 4 km/h. Obviously this is going to be 3 km/h. So if they ask angle, so then you can find the angle also. What is the sin theta? Sin theta is equals to opposite by hypotenuse. So what is this angle is going to be? So theta 37, right? So 3 by 5 means theta is equals to 37 degrees. If they ask you the angle, you can find the angle also. So and they just asked us to find what is the velocity of the river. So that's nothing but the horizontal velocity. Okay, clear? Chalo. So if they ask you drift, what is the drift? Actually, he, like if he starts here, he thinks that he reaches here, but he is actually reaching here. This is going to be the drift. You can find drift also. What is the drift? So the horizontal velocity into time taken. What is the horizontal velocity? 3. So what's the time taken? 15 minutes. So you can do that also. Or 3 km/h into 15 by 60. That's the drift. Okay now. So depending on the question and what they are asking, you can solve it on your way. Okay. Chal. So now the crossing the river in the shortest time. See, first thing is crossing the river in the shortest path. For the shortest path, so the simple thing, you should start with an angle theta with respect to the vertical to the west, right? So therefore sin theta is equals to VR by Vs is the condition. So now to cross the river in the shortest time possible, so the thing is, if you start swimming perpendicularly, so if you start swimming perpendicularly, so swim or row the boat perpendicular to the river flow, perpendicular to the river flow. So that's the thing. So whenever you start rowing or start swimming perpendicular to the river flow, so obviously due to the river flow, you will be thrown to the right. So this is the velocity of the river. So then you will make some angle theta. So this theta will have two components. So what is the, let's suppose this is a velocity of the swimmer. This is a velocity of the swimmer with respect to the perpendicular. So this velocity of the swimmer will have two components. So the vertical component and the horizontal component. This is going to be the velocity of the swimmer with respect to ground. This is a velocity of the swimmer with respect to ground. So the only thing that you have to remember is whenever you have to cross the river in the shortest time possible, so start swimming or start rowing the boat perpendicular to the river flow, perpendicular to the river flow. So clear this part? Understood? Yes, chal. So now, so can you guys take this question as a homework? Just the one question, take it as a homework from my end. So if you are not getting, so just let me know in the comments. I'll explain it in the next class. So but first try this question on your home. Okay, so homework and comment your answer. Clear? Chal. So chalo guys, so that's it for today's class from my end. So start preparing the short notes and do some extra questions based on these topics. Just don't look at the question, just take the question and try it on your own. So whether you are able to solve that or not, so just check it. Okay, so if you are able to solve it, well and good. If you are not, so then check again where you are missing the concept or you are unable to do the calculations. So just analyze yourself. Okay, so self mentoring is very important, because you will only know about yourself rather than anyone else. So that's why where you are committing the mistake, so first point that out, because you are in the early stage of class 11th. So to crack your competitive examination, whether it's JEE or NEET or WBJEE or any other state level examination, so BITSAT, anything you are preparing for. So the first thing, you should analyze yourself where I am committing the mistake. Am I lagging in the concepts, or am I doing the calculation mistakes, or am I not revising enough? So this self analysis is very important. Okay, so once you analyze yourself, so then you can focus on that point. Let's suppose your concepts are missing, then you can focus first on the concepts. So otherwise concepts are very good but your application knowledge is poor. So then what you should do? You should do number of questions related to that concept. Okay, so if some student who is doing quickly, if he is doing some 5 questions related to the topic, you do 10 questions related to that topic. Understanding? So that's very important. So or you understood the concepts and you are able to apply it, but you are doing the calculation mistakes in a hurry. So you should stop your anxiety while doing the questions. Okay, so these are the things that analyze yourself. You can only analyze yourself rather than someone is being mentored or someone is being guide you. So you can guide you in a better way. So as per my understanding, so the self analysis is very important. Okay, so adapt that guys and analyze yourself in a regular intervals of time and change your preparation strategy according to that. So if you are following the same preparation strategy from starting to end, if you are not getting the good marks, so that you are never going to get the good marks in the final examination also. So that's a hard fact. So if you are not getting now, so just change the preparation strategy. Okay, like some students follows all the lectures, so they remember, so they attempt the exam, like if it is a short test, they'll attempt very good, but when it comes to the cumulative examination, then they won't be able to attempt or they won't be able to recall all the formulas. So what's the problem? Because they are not revising daily. Let's suppose I am doing the 5th chapter, so and if I conducted the test on the first 5 chapters, so you are able to perform well in the 5th chapter and 4th chapter because you studied them recently, but the first 3 chapters already it's been a long time. You are unable to recall the formulas. So where you are lagging? You are lagging in the revision. So you should focus more on the revision. Okay, so these things, just analyze yourself and so do what is good for you. Okay, so chalo guys, we'll meet in the next session. So that is motion in a plane. So we are going to start the projectile motion. Before that, I'll do the distance of closest approach concept. Then we'll go for the projectile motion, where in projectile motion I'm going to take at least 2 sessions and maximum 3 sessions. Okay, so till then keep studying. All the very best.